Hi dear students, so welcome back to my session. In our previous session, we discussed ideal voltage sources and ideal current sources, and we drawn VI characteristics for ideal voltage sources and for ideal current sources. In this session, we will going to be discuss source conversions or else source transformation techniques. So this also comes under the same chapter, DC network theorems. Before discussing the theorems, we need to be know some small techniques. Then only we can solve those theorems in very easily. The techniques, one of the techniques is called source conversions. It is often necessary to convert the voltage sources into the equivalent current sources, as you know, or current sources into the equivalent voltage sources. For replacing one source by another source, another equivalent source is nothing but a source conversions or source transformations. What is the definition of source transformation or source conversions? Replacing one source by an equivalent source. The name itself, equivalent, is very important, which will come under your next slide. Mm, Replacing one source by an equivalent source is often called source transformation or source conversion. This conversion serves a powerful tool to simplify the analysis of circuits, especially with mixed sources, whether the current source and voltage source. Some of the circuits may have the not only complete voltage source, not only complete current sources. Some of circuits may have the mixed sources, like some circuits have voltage source and also current source. So while that type of circuit, it is critical to solve for the mixed sources. So for the simplification of that types of circuits, this is source transformations or source conversion technique is very useful. So before this source conversions or source transformation technique is possible only for non-ideal sources, or else we can say it as a practical sources, means practical voltage sources or practical current sources. As already you know what is ideal voltage and ideal current sources. Let me have a look about ideal voltage and ideal current source again in this slide. Already you observed this slide in your previous session. Please try to observe here also. Compare a voltage source to the ideal voltage source. Ideal voltage sources look like this. Let me add my marker. Right, ideal voltage sources look like this, but practical voltage source is look like this. If you observe here, this is practical voltage source. If you observe this slide, sorry, the voltage across its terminal A and B. This is terminal A, this is terminal B, remains fixed regardless of the value of load resistance that may be connected across the output. So here the value of this A and B is fixed across this. How much value of is connected to the resistance is doesn't matter for the ideal DC voltage source. For this, already you know, for the ideal DC voltage source, the internal resistance is Rs is equals to 0. Already we know how this is going to be 0. This is not possible in practical voltage source. That is name it as ideal. So this is for loaded and this is for unloaded. This is loaded and the internal resistance is not vary based on the changing of load. You should remember that point. This 0 also you should remember. So let me move to the next slide. Already you know the slides. That is the reason I'm moving very fastly. Practical voltage source. RS is the internal source resistance, and VS is the source voltage. If you observe the practical voltage source, if you see the practical voltage source here, the resistance will be present, right? Some value of resistance will be there. So that is the practical voltage source. So in the ideal, this resistance will not present. Instead of RS, in the ideal, 0 will be present. But that is the main difference between ideal and practical. So this is doesn't matter about the loaded. That is your interest. You can add the load. But unloaded means there is a value of resistance should be present. If you observe the practical, there is no value of resistance in the circuit. Wait. Right? Hope you clear. Next, practical voltage source with no load, the output voltage is Vs, right? The output voltage is Vs. This voltage is sometimes called open circuit voltage. Already you know, already I said in our previous session, um, This output voltage also you can you can name it as a terminal voltage sometimes. Sometimes you can name it as a V out. You can name it as V0 or VO. Some books they used to say VT. Some books they used to say V naught. So with the no load, the output voltage is Vs. This is voltage sometimes called open circuit voltage. When a load resistor is connected across the output terminals, if the load resistor is connected across these output terminals in this figure, all of the source voltage does not appear across the load because some of the voltage drop across this RS. Right? Hope you understand what I'm trying to say. Because this is input and this is output, right? This is my load. While you are consuming power in the this is the internal part. While you are buying any battery like this, there are battery in this subdividing parts are there. In the battery, there is a positive and negative terminals in outside. While the giving of the, if the battery is mentioned 24 volts of the supply, the output they may not have the 24 volts, they may have the 22 to 23 volts. What about the 1 volt to 2 volts drop? What about the 1 to 2 volts that will comes under the loss? That loss is nothing but due to the internal resistance, that is called RS. So in practical voltage source, that is that what I said in our previous session, ideal voltage source is never persist in our uh, in practical purpose. So that is impossible case. That is the reason there is a no ideal circuits. Always we have only practical voltage source which have the some internal resistance on the circuit. Every circuit has some internal resistance. There is no input is push output. Some drop is there within itself. So that is the reason you should consider. You should consider. Let me remove this. So this is input. This is output. Then this is loss. That what I mentioned in this point. Loss. This is called loss. Input is equals to, so the main formula of this is input is equals to, you should remember this formula of every form of energy, either it be mechanical, electrical, or thermal energy, or chemical energy. Always you should remember this formula. This formula is very important. Input is equals to output plus losses. This is, if this tends to 0 means that is input is equals to output. This is ideal case, never exists. This case never exists. So that is the reason input is equals to output plus losses. This loss I mentioned is a drop, that is called voltage drop. While the current traveling through this resistance RS, that will develop a voltage drop across this resistors. So in practical voltage source, that is the output terminals, that is the voltage across the output terminals. About this slide. Next, practical current source. Already we observed the practical voltage source, and let me move to the practical current source. This is practical current source. If you see the practical current source, let me observe the ideal current source. In the ideal current source, the resistance between these two terminals is infinity, right? The resistance between RS is infinity. Means infinity is no need to be mentioned the resistance value. That is the reason there is a no value of resistance. Since there is no value of resistance means infinity, there is no connection between this terminal to this terminal. That is the reason the total current is passing through this RL load if you connected the load across A and B terminals. Hope you understand. If I connected RS like this, whites by open circuiting, so there is no resistance between this C and D terminals. Since there is no resistance between C and D terminals, the total current will not flowing through this C and D because this is C and D is open circuit. The what is the value? What is the resistance of open circuit? Always infinite. means maximum value of resistance is there. That is the reason the current is doesn't flow from C to D terminals. Hence, the total current will trying to pass through this A and B terminals. Hope you understand what is the meaning of infinity, right? So this is an ideal current source produce a constant value of current through a load, regardless of value of the load. So this is the ideal case. Since there is a no internal resistance, means infinity value of there is a high value of internal resistance. That is the reason the total current is sending to load. Then Is is equals to IL will be comes to the picture. There is no dropping of current. Is is equals to IL. But in practical, this is not possible. Is is going to be sending through this some internal value of resistance, not in R infinity, some value of this resistance is there. That is called loss, small l, small loss resist, loss current is equals total current. Mean because input is equals to output plus losses. This is input, this is output, this is loss. So this is about this slide. But in practical source, let me see the ideal voltage source. The ideal current source has the infinity large internal parallel resistance. That is a parallel resistance which is infinity. This slide is similar to our previous slide itself. Let me go to the next slide. But in practical current source, represented as shown in figure, here the internal resistance appears in parallel within wherever I mentioned like this gap C and D, there is a internal resistance will be present. That is called RS. RS value of resistance will be present between this C and D. So the total current Is will not travel through this A and B terminals because there is a value of resistance is there. So current will not flowing, the total current Is will not flowing through this A and B. Some of the current flowing through the C and D and some of the current is flowing through this A and B. This is the practical current source. This is the main circuit about the practical current source. Always the resistance presence between parallel to the current source. So you should remember two important points. The ideal voltage source, the resistance always in the series with the voltage source. This point is very important. Please note down. Non-ideal or practical voltage source, the resistance always series with the voltage source. If you take non-ideal or practical current source, the resistance always parallel to the current source. So these 2 points are important, right? So this is practical current source with load. And as long as RL remains such as smaller than the RS, means RL remains smaller than the RL. Let me write. Smaller than the RS. The current through the RL will stay almost constant no matter how much RL changes. Please understand this point. As long as RL remains much smaller than RS. If RL is smaller than the RS, if this is the 1 ohm, if this is the 2 ohms, the current through the RL will stay almost constant no matter how much RL changes, because here always current always choose the least distance path. Let me understand in the numerical method way. If you take RS is the 2 ohms, if you take RS is the 2 ohms, RL is the 1 ohm, RL value of resistance is very less compared to RS, then the current always choose the least distance path, that is 1 ohm. Hence, there is very small amount of current which is flowing through this RS. Hope you understand. This RS will never change because this is fixed value RS. Because this comes under the internal. While you're buying the equipment itself have the internal resistance like battery, I said. So this is about the slide. Let me move to the next slide. So source conversions. So after the understanding about this non-ideal or practical voltage source and current source, now we are moving to the actual topic So actual today's topic is source conversions or source transformations. Conversion is nothing but already you know replacing one source by an equivalent source is called source transformation or source conversion. So first, let me convert non-ideal. If we convert non-ideal means practical practical voltage source, non-ideal voltage source to non-ideal current source or practical current source. Please mention this word clearly. Somebody some of the students they may assume this is the ideal, but this is not ideal. This is practical, or you can name it as a non-ideal. Ni or Ni, or you can name it as a practical current source. So this conversion is possible only in practical conversions, practical sources only. This is conversion technique not possible in ideal sources. So please note on that point clearly. So if while the observing this circuit, the conversion is very important. So here the conversion of voltage source to the current source, that is our topic. For the converting practical voltage source to the practical current source, we should depend upon these two equivalent circuits. This is a voltage source, this is practical voltage source, this is practical current source. So for the conversion, you should remember two important points. So what are the important points? Let me move to those points. So while you're converting of this circuit to this circuit, you should remember two important points is one is RL in the both circuit must be identical, means while the converting this to this must be same. Next, IL and VL in the left circuit, this IL and VL in this left circuit is equal to the IL and VL on the right circuit, means the current and voltage drawing by the load when in the voltage source or when in the current source should be same. I will repeat it. The current and the voltage means power across the output terminals will not be affected whether you convert voltage source to current source or current source to the voltage source. This point is very important, means this technique is only for the simplifying the circuits only, not for the changing the complete the real structure of the circuit. This is only for the simplification. For the simplification purpose, you should not change the actual working principles. So you should remember this point. After the changing of any conversions, voltage source to current source or current source to voltage source, the output current and voltage or output power should not affect. Right? Let me move to our first slide. Sorry, source conversion slide. Right. In this slide, converting a voltage source to the converting a practical voltage source to the practical current source. So conversion, this is conversion is going to happen from here to here. In this slide, where we are just converting practical voltage source to the practical current source from this source to this source. Let me have a look with an example. So, sorry, not with an example, with this derivation. So how this Is is equals to Vs by Rs to come to the picture means Is. This how this comes to the picture. Let me understand this principle. Is is equals to Vs by Rs. How this comes to the here by doing some derivation in our MS Paint software. Right. If you look at this, let me add this slide carefully. Let me remove this. Right. Let me take these screens. right? So in this, we are going to be convert from this side to, sorry, let me change the color, from right, from this is ideal voltage source. Let me write this is ideal voltage, sorry, practical voltage source to the practical current source. P, practical voltage source to practical current source. For this, for the conversion of A, this is like, let me write, this is C, this is D for the time being, please. Here, how this Vs by Rs comes to the picture, let me understand. For the non-ideal voltage source with the terminal A and B, it has the resistance of Rs, right? With ideal source, this is ideal source. Find the non-ideal current source with the terminal C and D, it has the resistance of Rs. Instead of mentioning Rs or Rp same, you can mention Rp also. Rp or Rs both are same, no need to worry about that one. It has the resistance of Rs. So suppose to convert the voltage source into the equivalent current source, short circuit the terminal A and B is need to be required. So while you are converting this practical voltage source to the practical current source, let me make one condition. Let me write that condition. Short circuit terminals of A and B. How you will make short circuit? Take a thick copper wire. Take the copper wire and add here. So I am making short circuit of this. Now my job need to be find this current flowing through the short circuit path. Right, let me find the current flowing through the short circuit path. This current I need to define. So I am naming it as that current is short circuit current which is flowing through the A and B terminals. How you are going to be find? So ISC, let me add that point here itself only. Short circuiting of A and B. Here ISC. Now my job need to be this, find the short circuit current which is flowing through the A and B terminals. For the finding of short circuit current flowing through this A and B terminals is equals to, as you know, Ohm's law, Vs by Rs, right? Vs, total voltage by resistance. The internal resistance is Rs. Hope you clear. So this is equation number 1. Let me name it as equation number 1. Sorry, this is equation number 1. So while I am doing the short circuit across A and B terminals, the current is flowing through this A and B terminals is ISC of A and B. I mentioned A and B. Now, similarly, short circuit current of the current source with terminal C and D short circuit. Let me do the short circuit across C and D terminals also by taking thick wire. Now, my job need to be find the current flowing through the short circuit again, ISC. ISC through this. So let me make that condition clearly. In the second condition, short circuiting of C and D terminals. While I'm making short circuiting of C and D terminals, in this, let me write ISC current, short circuit current which is flowing through the C and D terminals. is equals to how much current will flowing through this. Let me assume this current is is. Let me assume, instead of knowing this Vs, I don't know how much value of Vs is there. I don't know. So I'm mentioning. So let me remove this Is first. I'm removing this Is. Keep this aside. So instead of mentioning that Vs by Rs, let me add this is Is point. This is mentioning this is Is. Is. So let's tell me how much current which will is flowing through this C and D short circuit path. Here, how the current is going to be divided? Either maybe current is flowing through this RS or complete current flowing through the C and D. Obviously, the total current always choose the least resistance path. So means the supplying current means Is, which is a source of the circuit, is flowing through the C and D path, because here there is no flowing of current, because this is not short circuit path. Here the current is short circuit means the resistance is zero. When this is resistance is zero, there is some value of resistance is there. The zero resistance means the load value of resistance is very much less than the supply resistance, means source resistance. So always choose the current, always choose the least resistance path, right? Hence the current, the total current always choose this path, that is called Is. Hence Isc is equals to Is. Hope you clear. The current of this is Is. So let me repeat it. I am making the short circuit of A and B terminals for the finding of short circuit current through this A and B terminals. So I am doing the same condition for the both circuit. My condition is I want to do short circuit of this output terminals, that is whatever highlighted of this, that is internal resistance, whatever coming of these terminals are output terminals. My final point is need to be short circuit of this output terminals, either maybe voltage source or current source, that doesn't matter for me. So I need to short circuiting of this A and B and C and D. After doing short circuit, my job need to be find this short circuit current. While I'm finding the short circuit, here I got Isc of A and B terminals is equals to Vs by Rs. Here I got Isc across C and D terminals is flowing through the C and D terminals is Is. Now this, let me write this equation is 2. So as you know, for the equivalence, already we have a few conditions about the equivalence. Means here the conditions of equivalence already I discussed. The current flowing through this load means if I add this load, if this is the load point, if I connect short circuit path, the current IL will flowing through this, right? Am I correct? So IL will not change, right? Means the condition of IL and VL in the left circuit is equal to the right circuit. Hence, I can use that case, I can use that condition here. I am going to be equate this 1 and 2. Then only that is named it as an equivalent circuit. Hope you clear. So here I'm doing, what I'm doing is, for the equivalence, equation 2 must be equal to the equivalence equation 1. Hence, what happened here? Isc of AB is equals to Isc of C. What I did simple equation 1 is equals to, sorry, equation 1 is equals to equation 2. I name it as a equivalent circuit, for the making of equivalence balance circuit. So I need to be the same, means the output terminals after the converting this voltage source, my output drawing capability of power should not affect. That what I made the condition in the initial stage. Then the current flowing through this A and B after the converting to the C and D terminals, the current should not be affected. That is the reason I made this condition ISC of AB is equals to ISC of CD. What about the ISC of AB? As you know, VS by RS, let me substitute that value itself. ISC of AB is VSC by RS. Let me substitute this value, right, is equal to, what about the ISC of CD? Short circuit current across flowing through the C and D terminals where I am doing the short circuiting. So that will be, wait, so this is the final solution of conversion of practical voltage source to the practical current source, or ideal non-ideal voltage source to the non-ideal current source. So hence finally we got the formula IS is equals to, what the formula we are getting, IS is equals to how much, VS by, what formula we are getting, let me write that formula clearly. IS is equals to VS by RS, means while the making of this circuit, the current source we got, that is IS. So instead of IS, we can write this VS. So same, or you can write IS also. That doesn't make it is IS, or IS is equals to VS by RS. Both are same. So just you did only for the converting voltage source to the current source by making resistance across this circuit. Hope it clear. Means for the finding of IS, so means VS is VS by RS. Already you know VS, this is VS. As you know, the practical current source is nothing but here this circuit. The already you know the ideal current source is, this is ideal current source. The resistance always infinity across this circuit. When this ideal current source will be practical, when the resistance is connected across the resistance is nothing, across the current source is nothing but practical current source. Already we discussed this slide, this topic in our previous slide. So that is the reason I added resistance in parallel, I added resistance in series here. So when the resistance in series with the voltage source, only practical voltage source, when the resistance is parallel to the current source, then only that is named as a practical current source. So just I converted practical current source to the practical voltage source. Let me clear these points clearly, then it will be visible to you all. So you should remember this point, very important, and this derivation also very useful for you, right? So in the same way you can convert, means practical current source to practical voltage source. For the finding of practical current source and practical current source to the practical voltage source, here for the voltage source to current source, you converted, you added one important point, that is you made that A B and CD is short circuited. For the finding of current source to voltage source, you should make A, B and CD should be open circuit. Then only you can get the output voltage. Otherwise, you can't get this. Why? Because if I didn't make the short circuit across A and B, you can't measure this IS, right? You can't measure this is, because without making of short circuiting of this A and B, how the current will flowing through this? Makes sense, right? So that is a reason for the finding of, for the conversion of voltage source to current source. Understand my point? For the current source, you need to be short circuiting of the outermost terminals. Now for the making of current source to, sorry, for the conversion, for the converting of current source to voltage source, please note down my point clearly. For the voltage source at the output terminals, you should make the open circuit. Means instead of the short circuit, you should mention open circuit. Means VOC, like this: VOC of AB and VOC of CD. Like this, you should do the derivation of that part also. So hope you clear about this. Right, let me save this. So let me add this point clearly. Here we are, right. We did this derivation, just we converted, and the same we did this derivation. So let me write this clearly. Let me save this slide. So this is about the one source conversion, means voltage source to current source. This formula is very important. IS Let me say this is IS. IS is equals to VS by RS. Next, the value of RS is the same for the both voltage source and current. This point is also very important. For the RS, value is same, no need to be change of these values. Here the value only, while without changing the RS value only, the power consumption across the A and B or C and D terminals is same. The directional arrow for the current points from the minus to plus means minus to plus B, because wherever if this is mentioned minus plus here, then the current direction is like this. Always current direction arrows from the minus to plus. Already you know this point. This is some important basic point, even though I included in this slide. So this is not rupees, this is RS, means source resistance or supply resistance, right? Here the source conversions, let me see. Load voltage source, this is the voltage source. After the converting of this voltage source, this is the load value of current. If the resistance is given, instead of the short circuiting of the path, please listen here clearly. Instead of making the short circuiting of the path, if I connected the resistance across A and B terminals, if the resistance name it as a RL, how much value of current flowing through this RL? Obviously, IL value of current flowing through this RL. IL is nothing but a total value of voltage by, because these are in both in series, right? RS plus RL. Same value of current should be passes through this IL. That is our condition. Equivalent sources with loads, even though the adding of resistance, even though the increasing of resistance in voltage source, after the converting of the voltage source into the current source, the value of output terminals voltage and current should not be changed. That is the reason I included this slide. Here IL is equals to VS by RS plus RL. Here IL is equals to VS by RS plus RL also. You may get a doubt how this IL is equals to, both ILs are same, sir. If you're writing the current division rule based on this logic, IL is equals to, if you want to find this total current which is flowing through this IL, how this equations comes to the picture, you may got the doubt, sir, how this both equations are same. Here already you know this is based on the Ohm's law. IL is equals to total voltage by addition of this resistance, because these two resistance are in series, means RS plus RL will comes to the picture. But what about this, sir? How this is comes to the same, both the equations are same, how this comes to the picture? Sir, here you should apply the current division rule of this finding of IL, means IL for the finding of current division rule. This is instead of VS by RS, already you know this is IS, right? This is total current, already you know. VS by RS also called IS. In our previous slide is given clearly, this is IS, right? You can name it as a IS also. So for that, sorry, for that IS IL is equals to IS total current into opposite value of resistance, that is RS, by total value of resistance. That is only current division rule. Please, if you have any doubts on the current division rule, please go through my previous sessions, my previous classes, then you will understand. I explained clearly on that session about the current division rule and CDR and VDRs. Please go through that sessions. RS plus RL. Here that IS is nothing but a, how much value of IS is VS by RS. If you substitute VS by RS instead of IS, VS by RS into RS by RS plus RL, right? Here if you observe, this numerator and denominator is both get cancelled, then my total load current will be, means the current flowing through this A and B terminals is equals to the VS into, sorry, VS by RS plus RL. So this is not RL, this RS plus RL. So instead of writing this lengthy steps, I written I directly I take this screenshot of IL is equals to Vs by Rs plus RL. So my load current is never change, even though after done the conversions. Maybe voltage source to the current source or current source to the voltage source. Please understand this point, and this equation is important. IL is equals, don't by heart these equations, because if you know the Ohm's law and if you know the series and parallel current division and voltage division, this equation comes by default itself if you know the concepts, right? Then let's move to the next slide. For any given load resistance connected to the two sources, the same load voltage and load current are produced by both sources. That's what I said in our previous slide. So here, whatever conversions from the voltage source to the current source, why I am repeating this point is important this many times, because some of the students they do mistakes after the conversions. They used to change this all the values of this resistance and RL. They used to change all the values of the converting, and some of the students they may get the different load currents for this voltage source, and for the, after converting voltage source to current source, this IL is going to be effects. If the IL is going to be effects, that is wrong. So IL should not affect and VL should not affect, means terminal voltage and the load current should not affect. That what I mentioned this point. So source conversions, equivalency of two sources means that for any given load resistance connected to the two sources, the same load voltage and the load current are produced by both sources. This is called as a terminal equivalence. What I discussed about the equivalence on this slide. This slide also same and this slide also same. Both slides are explain the same point. So this is about the just one conversion, one transformation. Just in this session we converted ideal voltage source to the non-ideal voltage source or practical voltage source to non-ideal current source or practical current source. So based on the conversion we got Is is equals to Vs by Rs, or we got IL is equals to Vs by Rs plus RL. So that's it. This is about the today's session. We will discuss in our next section about the one more transformation technique, that is ideal non-ideal current source to the non-ideal voltage source. So we will discuss about the transformation in our next session. Thank you. Have a good day. Bye bye.